Hello, welcome to the P.2 Screencast. This is Ian Knoll, hopping in with question A. The first part of it asks why the set of even natural numbers does not have a least upper bound. And the set of even natural numbers does not have a least upper bound because it isn't bounded above. It extends infinitely in the positive direction, and so it cannot have an upper bound at all. And for the next part, it says explain why 0.99 is not the least upper bound, a least upper bound on the interval 0 to 1. And this is because to be an upper bound, a real number having the property that x is less than or equal to a for every x within the set. So we know that there are numbers that are greater than 0.99 that are still within our interval, our set, like 0.999 and 0.9999. These are all greater than 0.99 and within our set, so 0.99 is not a least upper bound or an upper bound. And so for part B here, we want to prove the following statement. If a real number a is the least upper bound of x, then for every epsilon greater than 0, there exists x within our set x such that x is greater than a minus epsilon. And we want to use a proof by contrapositive here. So the first part is going to be forming this contrapositive statement, which is going to be not Q implies not P. And since these quantifiers that we see in our conclusion are there, we're the negation of our conclusion that will begin our contrapositive has to swap these quantifiers. So we will begin with our conclusion that we are negating. So if there exists epsilon greater than 0 such that for all x within our set x, x is less than or equal to a minus epsilon, and that came from negating our inequality over here. And now we're going to negate our hypothesis. So our original hypothesis says if a is the least upper bound of x. So then a is not a least upper bound of x. And so now we have our contrapositive statement, which is logically equivalent to our original statement. So by proving the contrapositive, we will have proved the original statement. And to begin this proof, we want to start with our assumptions that says we know that epsilon is greater than 0. We were told that. And we know that x is less than or equal to a minus epsilon because we were told that as well. And so since we know that for all x within our set, x is going to be less than a minus epsilon, we can say that a minus epsilon is an upper bound for our set x. And this just comes straight from the definition of upper bound. And we know that a minus epsilon must be less than a because we were told that our epsilon is greater than 0. And a positive real number minus our a is going to be less than our original a. And because we know that a minus epsilon is an upper bound and is less than a, it's impossible for a to be a least upper bound of x, considering that we have a minus epsilon, which is less than a and an upper bound. It's impossible for that a to be the least upper bound based on the definition of least upper bound. And that concludes our proof. And since we proved the contrapositive, we have proved the logically equivalent statement that we saw originally. And that concludes this screencast. Thank you for watching.